Hi, I am Tanya Janka, and I am your host today. And we are going to talk about Chapter 3 of Alice and Bob Learn Application Security. That is this book right here. This is part of a series where we're going through the entire book. So I wrote the book, that's why I'm going on and on about it. And it's all about what is application security? How do we create secure systems? How do we make sure that the systems are secure that we think we made securely? And this chapter specifically is about secure design. So how do we find, first of all, the concepts of what makes something secure, and then how do we design it in? And so I brought some awesome guests. Let's bring out our awesome guests now. These are members of industry who are experts in this area. Awesome. So let's go around in a circle and start with Adam. Adam, could you please introduce yourself?
Sure. So, hi, I'm Adam Shostak, and I also have a book on application security from Wiley. Let's get this in front of the camera properly. See, Wiley, and it's Threat Modeling Designing for Security. And I realized yesterday that I've now been in application security for 25 years. A friend of mine became the new chief security officer for Fidelity Investments, and that was where I got my start doing this. And so I am super thrilled to be here with Tanya and everyone and to share with you some of what I've learned and hopefully learn some stuff from you as well.
Awesome. Vandana?
Hi, everyone. Yeah, I was speaking on mute. Hi, everyone. I'm Vandana. I am currently serving on the OWASP Global Board, and I'm really glad to be a part of the book series. When I got my book, it was amazing read. Like, there are so many concepts that I actually did not come across till now, and I got to learn. And from today's session also, I'm looking forward to learn from everyone. Thank you so much, Tanya, for inviting me to be part of it.
Oh, thanks for saying yes. Okay, Aaron, your turn, and then Ray.
Sure. Hi, my name is Aaron Lord. I've been doing AppSec now for about 11 years next month. I was previously with Zappos.com and more or less Amazon. And currently I'm with Workday Inc., basically doing a lot of what we're going to talk about today is talking about secure design, working with development, and doing code review and that kind of stuff. You can also check out, we run a blog, me and Ray, it's called Hella Secure. It's hella-secure.com.
Awesome. I was hoping that you would tell our readers about that. I read their blog. Ray, your turn.
Hey, I'm Ray LeBlanc. I am a application security architect for a healthcare company in the Pacific Northwest. Like Aaron said, I also write on the Hella Secure blog with him. Yeah, that's about it.
Nice. That's awesome. Thank you. Yeah. Okay. So I'm pretty excited to have everyone here. And I shared out the blog link for Hella Secure on the stream. And Adam and Vandana, if you want to share links too, you totally can. But I wanted to talk about chapter 3 and some of the concepts that are in chapter 3. And also, just to be clear, if any of you disagree with me, that's cool. And then that will make open discussion. Like Ray's really open to like open discussion / arguing. So at the very first part of the chapter, I talk about a design flaw versus a security bug. So by my definition, a design flaw is like the way that you're making, like it's like a logic problem, as opposed to like a security bug is the implementation. So like something coded incorrectly. What does anyone else think about these things? Or do you have opinions, etc.?
I mean, for me,
So-
go ahead.
So I think the thing that's thank you, by the way. I think that we just started talking at the same time. I think the thing that's interesting about the distinction between a vulnerability and a flaw is that everyone agrees we should fix the vulnerability. And sometimes the flaw is the result of a design trade-off where we're focused on usability or we're focused on performance or something else. And so I love the distinction, and I think that that property of it gets hard to fix might be useful to talk about today.
Yes, I agree so much. Aaron?
Yeah, so it's kind of the dichotomy of like all security flaws are bugs, but not all bugs are security flaws, right? And I think for me, a security flaw is a bug that violates one of the CIA triangle, right? The confidentiality, integrity, and availability of an application, right? So it's a fine line, right? Because you can even take 2 or 3 bugs that in sequence that may not be security related, but in concert may cause something that might be like considered a vulnerability.
Yeah, I feel too like when it comes to like a bug or like a coding issue, that's something that maybe an automated tool could find. But when it comes to a business logic issue, that a lot of the automated tools totally stink at finding those.
Yeah, totally agree with you. And if we don't care about the business logic flaws or the design flaws, that means whatever we do to fix the vulnerabilities, nothing will work out. We will see them coming. It will be there forever, whatever you do that. Like you are preparing to send out a tool or a product, and that's full of flaws. It goes up used by everyone, and then they come up, oh, there are some vulnerabilities. But when you go back and see that it's full of flaws, there are some design flaws itself. So which means you need to rebuild that product and then ship it to everyone. It has been the case with a lot of products which have come out in the past, and there are which are still part of the system. So we have to go back and shift. That's when shift left concept come into picture and start from the beginning.
I feel like you read my mind, Vandana, because that's the next part of the book where we talk about discovering a flaw later in the system development lifecycle. Do you want to explain what shift left or push left or what this left concept means?
Sure. It's all about checking, fixing, and finding the things early in the life cycle, even when we are discussing about it. Earlier, we were saying that we have an SDLC process, and we will do the testing at the later stage. Even when I joined the whole application security space, we were testing it in the later stages. And then there will be a security flaw that will come in when we go back and say that, no, you cannot go live, or there are challenges which are there. Then they will say, no, we have to do it. We'll say, no, you cannot. And for the fun fact, I'll give you an example. There was once wherein we found an XSS and SQL injection in the release, and we told them that you cannot go ahead and put it into the production. They said, no, we have to do it. They did something, came back to us the very same day. We spent the whole night in the office just for that. And after that, they fixed some broken things, just some broken things. We tried some other scripts, we tried some other SQL queries, and they worked again. And we were like, what you did? Then they said, okay, this is the script, and these were the SQL queries you gave. We just uh, resolved them. And we were like, were you supposed to just resolve them, or you need to do the input validation? And there were other things that we mentioned. So we had to go back and educate them. And that's when the whole shift left culture comes into picture, wherein you need to start the thinking from where a client start discussing, or let's say, even if you want to develop your own website or any product, thinking comes, okay, in the requirements, oh, I need these things in my product. I need to think about the security as well, here, because if I'll think about it in the end, then what will happen? The cost to fix that bug will be maybe 10 times higher, 100 times higher. And that's when the whole shift concept starts from the beginning and then come at each and every stage. And I think now learning and knowledge is also becoming part of this whole concept, which is not just starts from the beginning, but at each phase. And that's what we are doing here today. We're talking about secure
nice.
design.
I feel like I should just quote you in the book. It's like version 2, what she said. And for those that are watching or listening later, when we say left, what we mean is literally like right versus left. And when you draw the system development lifecycle on a piece of paper, oh, there we go. The further left you are on the piece of paper, that's how we came up with this expression. I did not come up with it. Someone else came up with the idea of shifting security left. But yeah, that is awesome. Okay, so like I feel, anyone want to comment?
So I had a conversation the other day where someone actually said exactly what we just heard about this cost being higher. And someone raised the question of why does the cost get higher? And so maybe that's useful to talk about as we learn application security. What happens is people have written some code, and other code takes dependencies, right? If that code is an API, then there's some dependence code that calls the API. And so the cost comes from, we wrote that code, and then we have to throw it away and write different code. And we have to go back to the dependencies and rewrite those. And we have to argue about, can we ship this? And that time late at night. And so that's where that cost comes from, and why shifting left can actually save you money and speed up delivery.
That's such a good point, Adam. And like the later you find it, you have to repeat all of those steps again. So if you already, like if you catch something in design and it's part of the design, you can fix it right then. But if you catch it during testing, then you have to go back to design, do coding again, and do testing again. And if you catch it in production, that's expensive. But if another person, i.e. a malicious actor that does not work for you, catches it in production, that's the most costly. That's really, really pricey. Oh my gosh, I agree a lot. So there's a bunch of things that we can do during a design phase to try to make sure that things are more secure. And I would say specifically like 2 things we talk about in the book and that I would hope we would talk about today. So one is, designing with secure concepts in mind, and the other one is threat modeling. And I was kind of hoping that maybe Adam would tell everyone what threat modeling was.
Sure. And let me start out with some definitions. So a threat, we use the word threat in a lot of different ways. And when we're talking threat modeling, I'm using it in the sense of the promise of future violence. So he threatened to beat me up if I didn't give him my lunch money. That sense is they threatened to take all the data out of our SQL database if we didn't block SQL injection. And so threat modeling is when we use models to help us think about what can go wrong before we've done any work. And should we pause there, or should I keep going for a sec, Tanya?
Keep going.
Okay. So the essentials to threat modeling, I'm going to teach you in 30 seconds. It is to ask 4 simple questions. What are we working on? What can go wrong? What are we going to do about it? And did we do a good job? And we can go into a lot of detail about how to answer each of those questions. But if you're answering those 4 questions, you're threat modeling. It can be very inexpensive. It can be super duper in depth. I'm working with some folks on threat modeling one of their systems, and this is an important system to them. I think we spent on the order of 40 or 60 hours with a team of folks really delving into everything. And so that spectrum of how much energy do we put in is dependent on how important is the thing we're doing, how big is the thing we're doing, what we're doing. I'm looking at the chat, and Ben is talking about some agile sprints. I wouldn't be spending 40 hours on something in an agile sprint because the scope of what are we working on is small, right? It's constrained. And so what can go wrong with that thing may also be more constrained, or it might be really big, in which case it's a really good idea to think about what can go wrong, what are we going to do about it, and make sure we have those answers as we're doing our backlog grooming so that we can make sure that the thing that goes to development, we've thought about that, the developers, the SREs can implement the controls before it goes live. I'm going to stop there because I think I just put out an awful lot of information in a relatively short time.
No, I think it's great. HelloSecure released a blog post about that. Ray, did you write that one? I remember really liking it.
So I believe both Aaron and I have written separate articles on threat modeling.
This makes sense.
Aaron's is Aaron's a lot better writer than I am, so his was longer and had probably more words that made sense. Mine was kind of more focused on the process that I use internally, which is kind of a very lightweight process. Go ahead, Aaron.
And it uses Adam's 4 questions.
Kind of, yes. It doesn't use the last question. We're not at the part of introspection yet, and it's a process. And getting the developers, so the point of my threat modeling process is to get the developers to think about security for 5 minutes, right? That is what my process is designed for, and then they basically develop this YAML file, and that YAML file is a receipt, right? So the way that I explain it to them is when you go get a massage, right? There's no physical proof that you got a massage besides the fact that you got a receipt when you paid for it. So that's kind of how I explain it to them. It's I don't really care about the document as much. I'm going to eventually review it. But it's the fact that you added stuff to this document and you critically thought about security and only security for 5 minutes while you were grooming this story. That's kind of really the whole point of my process is that, yeah.
Cool. Aaron, did you want to add something, or Vandana?
Yeah, I can add. So, one thing I really liked about Ray's recent post is that he did something that I have always thought about wanting to do, is to actually automate threat modeling in a fashion, right? By actually introducing some way that the development can actually kind of create some type of file that they can put inside of their repositories that can actually be automated upon to actually create some kind of threat modeling, like a threat model that could be displayed and layered on top of stuff. I think when I wrote about it, it was more or less, I wrote about the process of it, but I think the 2 points I was trying to make about threat modeling was, one is that it's definitely not an exact science. I wouldn't say that there's one perfect way to threat model. People are still trying to. That's why we have 4 or 5 different standards when it comes to threat modeling. There's Stride and Pasta and Attack Framework. I would say that even if you gave 4 like security professionals to say like, hey, go and threat model this one app that's exactly the same, I think that they will go through 4 different processes to get to the same result. And I think if you're trying to get into the industry and do this work, it is definitely a case of trying to figure out how you do this for yourself or how it works best for you, to like how to define your own process, because it's hard to follow someone else's exact process, right? You kind of have to discover it for yourself. And I'm sure we'll get into it again, but I think also threat modeling is not something that should be done in a vacuum, right? It shouldn't be done with just security people, right? You have to include the developers and the stakeholders of the project, because they know the app best, you know. And it's great to ask them questions, what they think could go wrong and how would they attack their own app, because they will have a much different perspective than a security professional will, and it's great to get that perspective.
Oh yeah. I like to invite some of the technical team to the threat model and the business stakeholders, but I've had some security people tell me you don't need to invite the software developers, it doesn't matter what they think. What does everyone else think about that?
I think
I've had security people say that. Vandana?
I was about to say, no, that's not true. And when people say threat modeling, now on the same lines, I've heard that people say that we do threat modeling once a year, once in 6 months. And that's not true. And when you said that, no, we don't need to invite this person or that person. No, when we talk about threat modeling, we need to do with a focus wherein we are taking care of the entire system. When you talk about an entire system, you need to invite each and every person, each and every stakeholder who's part of the whole process, so that it covers the whole bird's eye view, it covers the whole piece. And when it checks on each system, and another part is that it has to be action oriented. If there is a problem that we find somewhere, it has to be resolved. It shouldn't be like, oh, we have done the threat modeling, we have done our part, and we are done with it. No, it needs to include business risk. It needs to include many more things, which needs to be part of the whole exercise. Another concept, I was reading a few of the blogs from Adam itself, and I've read around threat modeling as a code, which is very interesting piece that has come up in the system. Wherein, how do you actually exercise this threat modeling as a code and bring the whole ecosystem into picture and start exercising that? Earlier, people used to think, oh, threat modeling is only needed at specific place or at a document or at this place. But no, it needs to be on the whole ecosystem. So that's my 2 cents on threat modeling.
So if I could jump in and add a little bit, I totally agree that we need to involve a diverse group of stakeholders. And everywhere in information security, I think we can do a better job at diversity, and especially in threat modeling, having people with different backgrounds, different perspectives really helps us do a better job, because we're getting those different views of what can go wrong. And so I really want to emphasize the value of diversity, especially here. But also, I want to go back. I want to pick a fight. Can I pick a fight? Is it too early?
No,
Okay.
let's do it. Let's do it.
So I'm totally good with having lots of different ways to threat model and lots of innovation in the space. But the thing I want to caution people about is, as you're getting started, don't try and learn 6 ways to threat model. Learn 1. And in fact, I'm going to give you some specifics. Learn to use data flow diagrams. Learn to use either Stride or MITRE attack as you do it within the 4 questions. And the reason I'm suggesting this is because there's a lot going on. We're talking about a lot of different things, about different perspectives, the soft skills we need to engage with people. And if you're trying to learn Stride plus Pasta plus Octave all at once, you're going to confuse yourself. And you don't need to do that. Get good at one, get comfortable with one, and then I totally agree with everything our co-panelists are saying here about varying up the diversity, varying up the deliverables, varying up the scope, all makes sense. But you'll drive yourself nuts trying to listen to everybody all at the same time before you know how to chop vegetables, put them in a pan, apply some heat, take them out. So there's my fight picking. Prove me wrong.
I've actually had a lot of like security professionals tell me, so like before I wrote this book and before I started speaking at a lot of conferences, a lot of people, I don't know how to say it, but they would just be like, I know more than you, you have to do it my way. And I had a lot of them tell me basically if I didn't do threat modeling perfectly, and if I didn't do it exactly to a model, so just me meeting with the devs and, you know, like the product owner and talk, like, what could go wrong? Like, what are you worried about? What's keeping you up at night? If you were going to hack your app, how would you do it? And just having an informal discussion to just get it on their radar and write down all of the risks I'm concerned about. They're like, that's not good enough. You're ruining things, Tanya. And I'm like, really? What does everyone think about that? Like, is it better to do a little bit of informal threat modeling that's only okay versus like just skip that time, you're wasting it? You can all laugh if you want to, but I had several people tell me that.
I spoke last, someone else go.
Oh, that means Ray has to talk.
Yeah.
Because I like to punish him.
So, yeah, I don't have a good answer for that. I mean, like, I hate doing, I like doing threat modeling, but I like that when the devs do it instead of me, right? Like, I work with one other AppSec person. So there's 2 of us. We have about 150 devs each that we kind of maintain through a security champions program and things like that. So we're like greatly outnumbered. Each dev is at any given sprint is working on multiple stories. Like I said, I like to keep it as light as possible. And there are exceptions on when we're working on auth systems and stuff, then that needs like heavy duty threat modeling, things like that. But for most stories, like the brainstorming kind of works, and I don't need to be a part of it. I'd rather not be a part of it, and I can see their output through the YAML. So I have little scripts that go and look for updates and things like that, right? And kind of email me whenever something changes. But like we have hundreds of services. Like it's impossible to keep up with any of that. Like the security team can't do it all. Like it's impossible. Like I don't even know a lot of the business cases. Like just getting up to speed on like why this feature was put in and what is the purpose of it. Like, well, like we have a bunch of different products and different segments of that product, and each are developing their own features, right? Like, how am I supposed to keep up with everything we're doing? It's just a losing battle if you don't find a way to scale it. And enabling your devs and teaching them that it's okay to be wrong when you're threat modeling is the best message that I keep on telling them. Be like, hey, we're all going to be wrong, but like, who cares if you put something in a YAML file and label it as a threat and it's wrong? Like, we just ignore it, right? Or we'll delete it later. Like, it's not a big deal. I know that doesn't necessarily answer the exact question you asked, but
It's good,
that's kind of how I
right?
feel.
It's good. Gary in the chat was saying, you know the old saying about models, all models are wrong, but some are useful. They are a means to an end, and a rough process that adds value is way better than a pointless formal process any day. I wanted to actually address Dominique's question in the chat, and Adam, since you're like responding, do you want to read it out loud for everyone and then like talk on that point?
Sure. So the question from Dominique here is an abuse case a form of threat modeling? And I think it is. I think that an abuse case seems like a way to answer the question, what can go wrong? So it's threat modeling. And to the point that was just being made, whatever works for you. It doesn't need to be this crazy formal thing. You don't have to use my structure or anyone else's. But the thing I do want to say is I don't see them working very often, right? There's a 1,000 academic papers and blog posts that talk about abuse cases. And I'm going to ask the folks in chat, have you seen them scale? Have you actually seen an organization that goes to abuse cases and uses them over and over again versus a once in a while sort of thing? Because I'd love to talk to anyone who succeeded with them. I'd love to learn from them.
Yeah, I've never actually used them. I've just done the models and then go make sure my app doesn't succumb to the things in the models. And also the things that the devs say during the meetings. So I once turned to two devs, and I said, if you were going to hack your app, how would you do it? And they said, oh, well, there's that like admin module that we made so that like we don't have to come in at night to do those updates. I'm like, that's not on the design document. That's not, and they punched a big hole through the firewall, had a full admin, everything in. It was so brutally insecure and bad. And and so we found it. And I was like, oh. And then I was like, why did you make that? And they said, our boss wouldn't approve overtime. And so we have to drive all the way across town, come into the secure building at night. You have to sign in and do all this stupid stuff. And it ends up taking like 2-3 hours to do like a 5-minute thing, and he wouldn't approve overtime for us to come in. It's like, well, I'm not coming in then. And the boss turned pretty red. Wow, cool, thanks guys. Anyone else?
They solved their own problem.
If there's one thing developers are going to do, it's solve the biggest problems that are in front of them. And this goes to the whole idea of a flaw versus a bug, right? They introduced a flaw. They knew they introduced a flaw, but they were solving a problem. And if we can shift, and this goes back to Vandana's point, that if we can shift to including them in the conversation and give them a chance to speak, they're going to help us solve these problems. We don't need to be the only ones finding what can go wrong.
Yeah. Does anyone else have any scary threat model stories they want to tell?
I would say the scariest thing is when I am tasked to threat model and there is no documentation or diagrams created or they haven't gotten to it yet. Because without good documentation and actually being able to diagram what the application is doing, it's nearly impossible to actually threat model. So, that's probably the scariest, most common thing that I would come across is that they just don't have the documentation in place for me to actually disseminate what this is doing.
What is this mystical thing called documentation? It's a new concept for me. I was a former dev, so that was a skill that I did not learn.
And I think it highlights the importance of a security culture, right? Because if you have a good security culture in tech, they're more willing to do those things that security may require that acquire of them, right? And also how detailed it is and how much they provide as well, because I've also had some that are just extremely basic. This is what it's doing, and then I get one diagram that lays out the entire thing from a 10,000 foot view, and it doesn't go any deeper. But however, that's also it's a big deal to build those relationships with development, and so you can actually go to them directly and start to ask them questions, right? Because I find that when it comes down to it, a lot of my reviews come down to just, going onto Slack and having a long question and answer session for a couple days. And that usually solves most of it, right? But yeah, having that stuff in place early makes the entire process quicker.
Yes. So again, I'm gonna argue a little bit here, which is that the process takes the same amount of time. It's just how much of it do we in security see or do. And my experience is there's never a diagram. And if we, and that's why question number one is, what are we working on? And that's really a very, very specific formulation, which seems sort of informal and tossed off. But it's we, not I. And if you go back 10 years, you'll see versions of it that say, what are you working on? And now it's always, what are we working on? And it's, what are we working on? Not what are we building? Not what are we delivering? Because I just want to get in there and have that and show value, where we can say, this is the thing that we are working on right now. It's the thing that's malleable. It's where the concrete hasn't dried. Yeah. And so I don't assume that there is ever a diagram or that there's ever documentation, or if it is, to Tanya's point, that it's they left off the fun parts because they know they're going to get yelled at for them.
Yep. I personally want a whiteboard, and I'm just like, hey, can we draw your app? So like, this is your app. Are there like any APIs? I'm like, cool. Just draw, and like, oh, does this connect here? Does that do there? How do you do this? Oh, it actually goes out here and then it comes here. I'm like, cool. And then I just like keep drawing stuff, and I always snap a picture with my phone at some point. I'm like, are we encrypting here and here? Could this person get here? And I just like kind of ask little questions as we go through it. I'm like, oh, how about this? And then sometimes they're like, oh yeah, we're doing that. I'm like, okay, cool. And then at the end, it's like, so I just made your diagram, your like design diagram, which is fine. And like, I'm like, okay, so I'd really like to see this here. And like, if you're gonna do that, that's cool, but we gotta harden it, or I gotta test it, or whatever. And at the end, they're usually like, okay. As opposed to, this is not acceptable, I'm gonna throw it in the garbage, and I think I have the authority to like back up your project 7 months. And I usually have to use persuasion to get the things that I want. Like, even if you're a consultant, it's like, I'm advising this, but they don't have to say yes. It's like, get out of here, consultant. Go away. Or we're just gonna do it behind your back the way we want to. I've come back to that lots of times. Oh, I thought we were gonna do encryption here and you weren't gonna roll your own. Nancy had some oh, sorry. Aaron, you go.
So yeah, and that brings up another edge case with any documentation diagrams, is that in our continuous integration world, that documentation goes out of date very fast. So a lot of the times, even if you do have that documentation and the diagrams from development, sometimes they may not be up to date. Like I recently, I did a review for a pretty major project back in December, and then come March, April, they've completely changed everything. So I basically had to start over. So working on it, knowing when it is malleable is key, right? So you can actually be working on it continuously, especially if the project is very massive.
Would you say, Aaron, as well, that like, so I have told people it's better to do some threat modeling than do none. And if you do it way later, if you have time, it's better than not doing it at all. Like, let's say they've released version 1 out into the world and they're now working on version 2. Like, I would still include a bunch of the version 1 stuff in the threat model because it's out there. And if we're updating for version 2, we could theoretically fix some of those things. Do you think it's like, I know we just talked about shifting security left and starting it as early as we can, and so doing it during the design phase, which is why I brought it up during the design chapter, is the best time. But what about in testing, or what about after it's been released? Like, if you start a year later somewhere and you're like, oh, that's kind of weird, it does this. Like, is it still valid?
Yeah, and I would say yes, because especially for me, threat modeling is not only just for the stakeholders, right? The threat model is also for myself because it helps to organize the test and the security that I'm going to be testing for in the future, right? It's basically my guide to move forward through the review, because generally my output from a design review is a list of security requirements, right? But those security requirements are a guide from myself once I actually go back and check their implementation and say, did you address XYZ 1, 2, 3 in the code, in the config, in the infrastructure? So it's also for myself to stay organized.
Awesome. So we have an amazing question in the chat from Ben, and then I kind of wanted to go over Nancy's complexity question. And anyone can answer, but Ben says, is there any formal security frameworks for implementing secure by design processes? I didn't share any in the book because I didn't know. Like, there is one from the Canadian government, but I wouldn't use it. It's very incomplete. Like, they cover a couple things, but it's so incomplete that I would never want to offer it as a model. So I just have a list of things in the book that I think people should account for, which we'll talk about after Nancy's question. But is there like a formal framework that people are aware of for implementing secure by design?
Are you talking about like NIST CSF or something like that? Like,
maybe.
I-
How would
Yeah.
that be applied? It's okay if we don't know. We're allowed to say that. The security, like cybersecurity and data science, are like the youngest subsections or fields within computer science, which is the youngest of the sciences, I think, or the main big sciences. So, like, yeah, I don't know, Adam? You are muted,
sure.
Adam. Oh,
Sure.
and Dana.
Yeah. So when I talk about the whole secure by design process, every organization is doing its own way. Because I have had conversations with many organizations and I've seen the trainings that they are providing. So this process is unique to each organization. But NIST is sharing a lot of recommendations, a lot of things that we can follow to have secure by design. Because secure by design involve multiple things. It talks about top 10, it talks about logging and monitoring and whatnot. So it has to inculcate each and everything step by step, and there is no formal process that we have come across. At least I have not come across wherein we can say that this is the standard that we should all follow or we can follow. So that's my understanding on that.
So there are a set of things. For example, there's SABSA, there's the open group reference security architecture. There are other reference architectures out there, and the reason that none of us sort of popped up and said yes, that is exactly what Ben is saying, which is that we need something that's usable and searchable. And there's a new book from Diana Kelly and Ed Moyle titled Practical Application Security Architecture or something along those lines. And as I was talking to them about it, their goal is to be lighter weight because all of these frameworks are so big, they're so heavyweight, and they don't help us get our jobs done. They help us get the framework implemented.
Yeah.
So the things that I like to see are like that it's not really a framework, but like it kind of gives you, I mean, it kind of gives you like a way to do things is like opinionated pipelines. I think Netflix, like, and their like paved road idea, kind of inspired a lot of people. Like having, here's how we build services, right? And here's the logging stuff. Here's how you do logging in our in our area, and it's very company specific right now. I would like to see it not so company specific, but everyone does software differently. Like when I worked at Zappos with Aaron, like we built software way differently than we do at my current company. That's a healthcare company that like has to care about things like HIPAA. Privacy is a much bigger concern. Not that privacy wasn't a big concern over there, but the
It's different.
the amount of how much we're concerned, and like that bleeds over into security. So I have to care about privacy a lot more, and work with the privacy teams that have a completely separate set of things. Yeah, sorry, I rambled on a bit about other stuff.
Yeah.
But yeah.
But that brings up a good point too, is that those frameworks change per industry, right? So you'd have industry of, again, health will be different from retail, will be different from, our public infrastructure, especially public infrastructure is very different. And you could even go up to like nuclear is its own thing, right? So those frameworks can change per industry. And actually, this discussion actually reminds me, I think it was an XKCD comic where it was like someone was saying, why are there 10 different frameworks for this? Why can't we just make one framework that just combines them all? And then the last panel, it was like, now there is 11 frameworks. So it's also a line to say, like, where does it start and end, right? And how far do we go in trying to redesign frameworks again and again and again?
Going back briefly to what Nancy was saying in the chat. So she was reading Too Long Didn't Read Sec, which is a newsletter that I subscribe to and I really like, by Clint Gibbler. And so Clint shares this blog post by someone named Phil Venables that basically said complexity is not the enemy of security. It's bad design. All useful things are complex at some level of abstractions. To wish the complexity away is to fail to apply good design and to actually just deal with it. And so Nancy's question was, can we embrace complexity even with a light and extremely quick threat model? Thoughts? I feel the question's really open. Okay, well, I know everyone's speaking at once. So I would say that it depends on the complexity, but also just, so Adam's 4 questions, like, what are we working on? Like, what are we doing to, like, secure things? Like, I don't know, I want to say all of the questions in a row and I'm messing them up all in my head because I'm on the spot, but, like, are we doing a good job of this? What are we doing about this potential issue, etc.? I feel like you can ask that about a simple problem or a quick problem. But whether it's going to be extremely quick of a discussion, if the system's quite complex, probably not. And if a system's really complex, you have to make sure all the people are there that understand all the different parts, right? And so if you have like a 10-person team and there's like 20 different services that all interconnect and this and that, etc., it's going to not be a short session, right? And maybe you need to break it down into little parts, and then you end up having 10 meetings with like smaller groups to figure it all out. But I don't know if you can do an extremely light and quick threat model if the system's really complex, but I don't think that means we shouldn't do it. Also, someone's mowing the lawn behind me, and I'm sorry, I have the windows closed now.
I mean, I think a light threat model for a complex system is better than no threat model for a complex system. At least you're capturing something, right? Some concerns that you have. So, like, if you can't do a full threat model with all the data flow diagrams that you want and wish for, all the documentation, at least getting some threats documented and getting tickets created is better than nothing.
So yes. And one of the things about what Phil was saying is that all systems have complexity to them at some level. And it's how much complexity do we need to grapple with? And this really goes to me to the question of what makes a model good, right? Not right, but good, is that it picks up some piece of complexity in a way that's helpful to you, because the reason that Tanya and I love whiteboards is in part because they allow us to sketch and to adjust, right? I can thumb off the bit that I don't like and redraw it. But this is, you're laughing, but this is one of those weirdly subtle things that we forget because it's literally in front of our faces. Is we do this sketching and this redrawing because our systems are complex, and we're grappling with the question of how do we make this complexity into something manageable so that we can do our security analysis and we can do our security design on it. And that is why this is 4 questions that I can rattle off in 2 seconds, and it's okay to get them wrong. But it's also, there's some real skill to develop and some real value to practice.
Yeah, yes. It's you know how you don't just do yoga one time and then you're flexible? You have to continue to practice it over and over so that your body remembers, oh yeah, I should be able to touch my toes. I should be able to bend over without my back hurting, etc. And I think it's this, yeah, you're like, that's not true. If I'm going to be good at threat modeling, I have to practice and continue to sharpen my knives over and over again, like sharpen that skill in your brain over and over again so that you can still see all the threats. Oh, I really like that. We have to briefly say goodbye to Vandana. She is all the way from India to this call. Thank you so much for being here, my friend. I really appreciate your
Thank
input.
you. Thank you.
Thank you. Thank you so much. We didn't want her to just disappear and everyone's like, is she okay? Where did she go? I know. You just have to deal with us now. No more Vandana for us today. There are so many good questions in the chat. I'm just gonna, if we go back down, does anyone want to comment on it? Because like sometimes I feel like the chat that goes on is so good I could just like read and hang out in the chat, but that's not appropriate because I am the host. Eventually I want us to wrap up threat modeling and then briefly go into 1 or 2 of the secure design concepts and then go into the questions at the end of the chapter, because these sessions are usually around 2 hours and we're getting close to the 1 hour mark. And I could like literally keep all of you here all day if you would allow it. So one question in the chat is, what methodology is good in threat modeling like Stride? And I don't know, that's the one I like. That's the one that I find the easiest to understand personally. I've never really I show an attack tree in my book, but honestly, I've never really, it's never clicked. It's always been very hard for me. Thoughts?
I think Stride is kind of like the go-to default for a lot of people. It's easy to understand. It's easy to explain. You're using like documentation and diagrams that like already exist in the developer's workflow or should exist in the developer's workflow, like the data flow diagrams, things like that. Like, I don't know. Yeah.
Adam just shared in the chat, STRIDE is an acronym. So it's the name of a methodology, but it's an acronym, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Adam, did you want to tell the audience a bit about what you've been working on?
Sure. So before I do, I wanted to just comment that I use Stride as my first go-to because it's a mnemonic. I can remember it. I don't need to have a whole kill chain diagram in front of me. But I did, and I think this is perhaps a transition point. I wanted to share something that a set of us have been working on. 15 folks who are threat modeling experts came together, and we created a threat modeling manifesto. And hopefully it is in front of the camera and the camera is not focusing on my face. But look, Nancy has the URL here. And there's a set of values, a culture of finding and fixing design issues versus compliance, collaboration over methodologies. And so as you're learning to threat model, and as you're rolling out threat modeling, we created the manifesto to help you to be an accessible resource, to be a resource that's really the result of a collaboration across a set of experts rather than, well, all of us are very opinionated, to be honest, but rather than having any one person's opinion at the forefront, it's a result of all of us working together to help you learn to threat model and learn to deploy threat modeling within your organizations and make it, as Tanya says, a practice that you return to over and over again. Someone else should come in. Should I keep going since I'm at the center of the screen here? So I love MITRE ATT&CK, and I find it to be a great complement to Stride, and it really helps you follow the chain that an attacker might follow in a way that's different from Stride. And when I teach threat modeling, I teach both Stride and kill chains, and I find that about half of my students gravitate towards Stride, half gravitate towards kill chains. Attack is very popular in that space. And so, which really, this is one of those, whichever one is working for you can really be, go with that rather than believing that you've got to do it the way Adam says or Tanya says. And let me just tie that to what I was saying earlier, which is that I suggest starting with Stride because it's a coin flip. And because I want you to learn one thing well before confusing yourself backing and forthing between the two. And so I tell people to start with Stride, but you could as easily start with Attack and have a good probability of success. And Hema, the best... Oh, actually, that's a more complex question. Now that Tanya is back, I'm going to hand the mic back to her.
Hi. Sorry. If you have enough caffeine, eventually you have to visit the ladies' room briefly. So there's more questions about threat modeling, but I also wanted to be able to cover some of the secure design concepts that we talk about in the book. But I also want the audience to really enjoy this session, and I'm enjoying the threat modeling questions, but let's just do the one last question from Hema on threat modeling, and then let's move on to the secure design concepts. So Hema is saying, so what are your thoughts on implementing threat modeling for legacy applications if they don't have a threat model already? And what's the best approach? I'd have to say I would wait until I knew I had some time where they might actually action any of the stuff I was doing. There's no point in like spending some time doing a bunch of threat modeling on apps where they're just going to ignore you. What does everyone else think?
I think that's a good point. I think as a security professional, like your time is limited with how much you can do, and if no one's going to take any action and really fix anything based on your threat model, like it may be worth it to get to it eventually. But I don't know. This is a hard question. I guess it's like I threat model legacy apps sometimes, and sometimes things get fixed and sometimes things don't. But I think where it really helps me is having the conversation of, listen, are we going to like fix this app? Are we going to accept the risk? Are we going to sunset it? Or there was a fourth option. I just can't remember off the top of my head what that fourth option is.
Just leave it on the internet super unsafe.
Yeah.
With Gary's thought is just wait until the legacy system is breached. Then the business will care. And he's being sarcastic, just to be clear.
No, he's not. He's so right. What I was gonna say, and I love Tanya's answer. I love Ray's answer. And the thing I would add for Hema is wait when the first question I ask is, what are we working on? And eventually, when you're threat modeling and you're showing that this works and execs believe you, they will ask you to go and threat model some of these legacy apps. And then you tell them, you're handing me a can opener and there's a whole can of worms back here. Is that the thing you want us to be doing?
Nice. Whenever I go consult somewhere, I'm always like, we need the nightmare list. We need the list of things that are keeping you up at night that you're really concerned about, and I want to reduce the risk on those things. So you have these 3 legacy apps that you know are a total disaster, that you've never had a pen test on, that have never had any secure coding things done on them, that should have been taken out of prod at least 5 years ago. And they're still business critical. And then you just keep asking me about, oh, well, we're building this brand new microservices, blah, blah, blah. And I'm like, I should only be spending half of my time on your AppSec program and the new stuff. And until I get this nightmare list down to 0, like the super terrifying things, I'm like, just give me some money so I can put some RASPs or WAFs on top of it and do some network segmentation and just like make it its own island of awful. So at least if something gets in, it only gets there. You know what I mean? Like, can I put Band-Aids all over it? And they're like, yeah, but that costs money and we don't have budget. I'm like, well, you're gonna have a law security budget soon after we have our breach.
I saw an awesome tweet the other day, which is that ransomware is just a penetration test where you negotiate the terms of engagement and the price after the penetration test instead of before.
Oh my God, I saw that.
That's great.
So true.
I think on the topic of legacy code, and I remember I saw a tweet a few weeks ago I thought was great, is that I'm just going to start calling legacy code vintage code. And just hopefully that term will just now dissuade people from not wanting to have stuff that's vintage. I think in my case, though, I know at Zappos I had to deal with a lot of legacy apps, but I think at Workday I've been so busy dealing with all the new stuff that I don't even have time to work on old stuff. And that happens with a lot of companies, right? And especially when it comes to really big companies, because Workday's pretty big. We're like 16 or 17,000 employees. So we like our AppSec team doesn't have time to worry about the old stuff anymore. And to the point that sometimes we just have to bring in other consultancies or third parties to look at the old stuff because we're too busy with new stuff. Because we have new stuff to look at multiple times a week.
Yeah. Yeah. Also, someone was asking how can Zappos has even been around long enough to have legacy, and someone said since 1999 they've existed. I had no idea. So
Yep,
it's like
they had
shoes.com.
they had some.
I think
they
that's
did
what it
have-
was, right? Shoes.com.
I believe it was. I think it was shoes.com. Now I think about it, I'm trying to remember now. But yeah,
So-
they had legacy apps for sure, and they were piles of spaghetti code. So, and they were in Perl.
You can have a legacy app that is 1 year old. Like, I mean, that is completely possible, right? And also to Aaron's point, like calling it vintage, I'm not sure if that's the right idea, because then you're going to get like all the developer hipsters being like, I'm going to create vintage apps.
Yeah.
My app loads off a record player.
Yeah. See, you say that now, but in like 2 weeks, there's going to be a GitHub project that like someone is going to do this, man.
No.
Yeah,
So
like,
BIOSes still include code to load off of cassette tape.
Wow.
I saw a project that actually was booting a PC, like a modern PC, off of a tape player.
Reel
That's
to reel.
disconcerting.
Not reel to reel, cassette, like Walkman style cassette.
So
Like
that's
a
even
cool
more vintage.
style
I want to go
cassette.
even further back. I want to use little tickets that you punch holes in.
Oh no. Oh no. Yes, my aunts and uncles have told me about the time of the computer, the punch cards. Yes,
Hollerith
definitely.
cards.
Gary has a really good question, and then I swear we're moving on to secure design concepts.
Okay.
So Gary was saying a metric I really like that isn't used very much is the cost of downtime. So should we encourage cost of breach as a tracked system metric? I say yes, definitely. I think that with incidents, like any security incident, just estimating like how much downtime, how many hours it took from each team where they're not working on their projects, and include that in your final postmortem of like, this is how much this cost. Sometimes they think it didn't cost very much because they didn't have to pay a ransom or something like that. And it's like, yeah, but your AppSec team couldn't do any work for 4 weeks, and all these devs were pulled off their project. This project manager, this and that, we had to do this, and it actually, when you add up all the salary hours, it cost us $75,000 actually to respond to that incident. And then they're like, oh. Any other thoughts?
Cost of breach is really hard to figure out. Like you have to be your company has to be really have their shit together to know the full impact of everything. I mean, like, so in heavily regulated industries, like those companies probably have a lot better idea of how much it's going to cost per user record, like to send notifications out, possibly. So I work in the insurance industry, right? So we know how much it's going to cost, like per user record, like because we have different state laws, and depending on the state laws and things like that, and like, but the hard part is reputation and brand damage, and that's a lot harder to figure out, and like the time it takes, we know how much we get paid and stuff like that, so we have a pretty decent idea, but like it's not an exact, like we don't have an exact amount.
So the reason I'm wincing is because that the team at Scientia, who are some of the folks who used to write the Verizon data breach report, have talked very extensively about how cost per record is a poor predictive tool, and I posted into the chat some of their links about cost of breach. and I want to go back a little bit to what Gary was asking about, which is, can we use it as a tracked metric? I think is very different than can we predict what it's gonna be, because these things are so weird. If I were to tell you that someone breaking into an HVAC system is going to be one of the most expensive breaches in history, and I was talking to a lawyer recently who told me that the Target lawsuits are still going on 8 years later, and they're still spending, I think he said, 8 figures per year on legal fees in that case. I would have laughed at you before Target had their breach and said, an HVAC system, let's get serious. And so it's really tricky to be predictive. And I think we as security people sometimes bring out these big, well-known breaches to say, oh my gosh, we do this and it's going to cost us both arms, a leg, and the next 10 years of all of our lives. And execs look at us and say, well, it hasn't happened yet, so I'm not going to worry about it that much. And so I think it's tricky to do this one well.
Yeah, you're true. Now that I think about it, like, when companies do get breached, like they get into agreements with like either the federal government or different state entities, and like they have to commit to also spending X amount of dollars for security program like each year, and like there's a lot of you're right. There's a lot of factors that like my original answer didn't even take into consideration.
I'll mention the Verizon 2021 data breach report came out 2 days ago. So there is new data on this. I have not had a chance to look through it yet.
Me neither.
I wonder if insecure software has been number one, like it has been every other year for a decade, as the number one cause of data breaches.
It's been going up every year, more and more.
I know.
I think web apps are like number 2, and I think social engineering is number 1 for something. I can't remember. I saw like a little picture on the internet somewhere.
I think phishing is the number one cause of a security incident, but the actual data being breached tends to be web apps.
Yeah.
Unfortunately, I heard that it's supposed to be web APIs this year, and I'm like, what's the difference? Like,
it's supposed to be. Who sets these things?
Yeah, so a few weeks ago, someone told me that that's what the answer was going to be. I'm like, oh, they've already decided. Okay, gotcha. I mean, like, we're not even technically halfway through 2021, and they've released a report, so, you know.
Don't worry, the budget will still go to all of the legacy security systems that it's always gone to, so...
Yeah. So
well, they're working so far.
Real quick, I actually just pulled up their summary of findings. Social engineering is still number 1 for breaches, but basic web application attacks is number 2. Which I think was the same as last year, so it's still on that trend. But I think basic web app attacks is around the 25 to 27% of all breaches. So at least a quarter.
Wow. That's a lot. So,
that's a lot of job security.
Dominique is saying, is the report of 2021 based on data from 2020? Or okay, so that makes more sense then, because I was thinking, so they're basing it off of just like 4 months worth of data, because they would need time also to write the report. So it's
been a busy 4 months.
Yeah. Cyber criminals and nation states have been very, very busy. They have not laid down on the job at all. On that topic, like briefly to bring us over to some of the secure design concepts I talk about in the book, I wanted to get some of your opinions on some of these things, because I have opinions, but when I explain it to devs, they don't always agree with me. And one of the things is I believe there should be a segregation of production data. So I don't think we should have copies of production in QA and dev and all the other environments. But when I was a dev, at almost 100% of places, that's what I had. And we could just look up how much money people made. And we could just look up secrets and other things. And the security team, I remember them telling us, well, we're going to take that away from you. And I was like, well, what are we going to test our apps with? But then I worked on security teams, and I was like, we should, jumble all of the data, mask it, as it's called. And I remember the QA team saying, well, we have these automated tests, and the answer is no. And they had more authority than I did. There are more people on the QA team than me, the entire AppSec team. And they're just like, no, Tanya, you lose. I was like, but. What are everyone else's thoughts? Like, why? So first of all, do you agree? And why? Like, why do we not want devs having access to prod data, or have dev systems have access to prod data?
So I would say that, like, the lower environments aren't monitored. They aren't secured the same way as production environments, right? So, like, internal, like, just looking at an internal threat actor, like someone internally has access, a lot more access to information in a dev system than a prod system, hopefully. But, like, externally, like who's looking at the logs for and all the monitoring alerts for a dev instance that's connected to the internet? Like, probably no one, right? If you're comparing that to the production instance, where they're like, hey, this service is acting weird, we have to go do something, and there's an investigation. Like, in dev, it's just like, oh, the service is acting weird, well, someone's probably screwing around with it. Like, it's not a big deal. I would say the hard part, though, with the devs is, like, synthetic data is hard. There's not, the solutions out there are super expensive because there's like 2 or 3 of them, and I don't even know if they're all that great. And then you can get into, like, talking about, like, de-risking or de-anonymizing or anonymizing data and stuff like that, and using that data, and then it's just like the risk appetite of what your company's willing to do and how much money they're willing to spend, because, like, none of that test data is free. So, like, it's really hard, and it's kind of falls into a business call and the risk appetite of the company, and until there's a solution out there that makes it easy to generate that synthetic data, and there's not really one out there.
But why don't we want devs to see production data?
Well, I mean, that's easier to answer, I guess. Like, devs,
They don't know.
Like, I mean,
These
it's
are
production
fine.
data, right? That's the crown jewels. Like, you don't
But
put
don't
all
we
the
trust
money
our
in the bank
employees,
out
Ray?
on the counter and be like, okay, take what you want and just, like, write us a note saying that what you took, right? Like,
I think in a lot of cases there's, especially if you're an organization that's taking customers' data, there's usually some kind of agreement or a privacy agreement or a service level agreement saying that only certain people or systems will have access or custody of data. So generally, breaching that with someone who's not allowed to access it, like development, is now breaching the agreement of the customer, right? And again, maybe a lot of times customer wouldn't know this, but if they did, that's already like a lawsuit, right? But I know, like, for example, at Workday, we're very, very stringent on how we handle our customer data, because we handle all customer data exactly the same, and it doesn't matter what type of data. It could be credit card numbers, it could be bank account numbers, or it could be someone's, like, public work phone number. If they give us the data, it's all encrypted and segregated from all other customers. And the only people who have access to it are those customers, right? And we explicitly state that in everything that they have to sign to be a customer, right? So if we have anyone accessing the data that's not explicitly pinpointed in that agreement, then we're breaching a contract. And that's going to be the same for a lot of companies that have these agreements.
Yeah. In the chat, Gary was bringing up GDPR, which, for those listening who don't know, it is legislation created by the EU, European Union, about privacy for customers. And I am not an expert on it, but basically you have to tell customers what you're going to do with their data, and then you're not allowed doing other things with it. So for instance, if you give your data to be on their mailing list, but then they sell your contact information to a bunch of marketing companies, they have violated GDPR. Are you going to be able to catch them? Probably not. But theoretically, you would have legal recourse if you live in the EU. In Canada, we actually have fairly strict privacy regulations. However, we never actually enforce them usually. We're very, very ridiculously, sillily lenient, which is very Canadian of us, and frustrating as a citizen, because the EU will swoop in and be like, we are the EU, ah! And Canada's like, oh, sorry about that. It's like kind of rude when you did that thing with our data and stuff. Could you just stop? I actually was part of a medical data breach in Canada, and I reported it to the the chief privacy officer of Canada, and they basically told me that, well, they said sorry, and they gave you 10% off your next purchase of medication, so you should be fine. But it identified all of us to hundreds of other people of having a specific medical condition. And to me, that's serious. And then someone forwarded it to a journalist. And to me, that was not acceptable. And they're like, oh, well, they said sorry. And like, they gave you 10% off your next medication order. I'm like, I don't care. And so we have really good laws that we never enforce. And so GDPR is like strict and is enforced. And I have to say, I'm a little envious. Does anyone have more comments on that topic? Because there's like a bunch of stuff in the chat, but there's so much. Does anyone want to cover any of the things in the chat? Because we have super smart humans in the chat, but we don't have to if you don't want to.
So, I mean, I could key on again the word of like custody of data, because there needs to be, if there is a breach and something does occur with customer data, there has to be a chain of custody of where the data could go. So by allowing certain groups access to the data, that makes the possible avenues for data to go even more complex for an investigation as well. So it makes sense to make it so that if there was an incident, that the places the data could have gone is reduced.
Yeah, I like that too, Aaron. Okay, I want to ask the questions at the back of the book. It's happening. So for those of you that own the book at home, obviously all of you bought the book that are at this, which is available from Amazon and all the other places that you get books. But the first question, there's more chats. Yeah, GDPR needs to be worldwide, i.e. Canadian companies who have European customers need to follow it. Yes, they do. Yes, they do. I'm very pleased about GDPR because it protects me inadvertently. Thanks, European Union. Okay, so the first question is, when should data be encrypted? Select all that apply. So this one's like a multiple choice. So A, when an API sends data to another API. B, on a virtual machine that's powered off. C, when stored in a database. D, when sent from the server to the browser. Which of these?
E, whenever you feel like it.
No, it's all of them. It's all of them.
Yeah,
Oh
why is there
the developer remembers?
Yeah, the developer, yes.
Yeah.
No, I'm gonna go with your answer, Ray, and go with E, all of the above.
Yes.
Yeah, I like that. That's the answer.
Yeah, agreed. All of the above.
Oh, so most of these are more like, they're not multiple choice. Most of them are like discussions. So the second question is, what are some possible ways that we can ensure the third-party components that we use are secure? How can we minimize risk in this area? I know this is one of Ray's favorite topics, but all of us can answer. But Ray, if you want to kick off the thing about protecting us from the risk in third-party components, because you ranted about it recently.
I hate third-party components. They're hard. There's like everything is like high or critical, right? Like all the CVEs are just like a mess, and they don't actually give any great information on whether or not your application is actually vulnerable to this, to whatever library or framework or whatever system you're using, right? And that's the hard part, is just like, so I mean, like, usually the things that I suggest for this would be like just keeping your third-party libraries up to date. I mean, you do run into other risks, like the supply chain issue, like security issues of what is it, the SolarWinds crap, right? Where you can either have your known risks or like verify your supply chain, and like really verifying your supply chain, how well can you do that anyway? So I generally tell them, keep everything up to date. It will make things easier for you, but I would say the biggest thing is just know your risk. Like catalog what you have, and that's probably the best place to start, and then make smart decisions from there.
Okay. Anyone else?
So first, I just want to defend the CVE. We never intended that it was going to do those things, so you can't blame it for not doing those. It's outside of spec. But secondly, more to the point of Tanya's actual question, I like to teach people to do one simple thing before they incorporate an open source library, which is to go look for a security page for the library or for the code. Because if it doesn't have one, or you can't find it inside of 2 minutes, they are not yet thinking about security at all. So you probably don't want to use that one. And so it's a super easy, understandable, everyone can do it, sort of, don't bring the bad stuff in. And the second thing is for everything, for your code, for other people's code, sandboxing, isolation, the jargon of limiting the blast radius is big these days. So if you're going to bring something in, know what it can touch, know how far it can go. And so what are we working on? We're bringing this big thing in. What can go wrong? Oh, it can control all of our network infrastructure. Well, let's make sure we pay attention to that, and we apply some protect, detect, respond capabilities as we're bringing it in. So those would be my two answers on that one.
In the chat, Ben is suggesting so you can fork the required dependencies to your company's GitHub to avoid someone hijacking the GitHub repo and then injecting malicious code. And Ben, I have to say that I did that for this. So there's like this workshop that I would give in Azure using ARM templates that were made by Microsoft. And I'd forked them because I am a control freak and I didn't want them to one day hide them. Well, the night before I gave training 2 weeks ago, they had removed the repos, and I was like, that's okay, I have my own fork. But there was a dependency within a dependency within a dependency, and they had removed it, and my entire workshop was screwed, so I got to stay up like all night rewriting it the night before I had to give it. But the joke's on them, because my workshop's twice as good now, and they hired me back to teach more. But that sucked. And so you have to be really careful if you fork a dependency, or if you fork something within GitHub, because I would never have assumed. So there was some sort of tiny like folder, and then a blob, and then a JSON file that was in somewhere else. And I was like, why? Why would you do that? And I was like, and then I said 4-letter words about my previous employer, and that was a thing. I was like, thanks, guys. And you wonder why there's no Azure training on the internet.
Also, if you fork something like that, like, I mean, you're now responsible for keeping that fork up to date, and you're just going to have a fork that has been brought over once, never touched again, and whatever vulnerabilities are in it, like, that's what you're going to be using for the end of time. Like,
yeah, there's complication there for sure. I would also say, like, if you're trying to protect against the third-party components, like one thing you can do is like use a software composition analysis tool and scan them, and it can tell you there are vulnerabilities in this version of this framework or whatever it is. We don't know if you're vulnerable, or if it's exploitable within your app, but you do have a little time bomb in your app, FYI, right? And that's one way. Another way is like looking to see if anyone's supporting it. So my company, SheHacksPurple.com, go check it out. That was my marketing. Was it subtle? But basically, like, we just launched a brand new website this past week, and it's built in WordPress, and I had like some designers make it so pretty. Everything I make is ugly, and that's fine. All my apps I ever wrote when I was a dev were ugly, but they worked well. But the point is that I went through every single component that they wanted to put in there, and I reviewed it personally. I like looked it up. Is someone supporting this? Are there any known vulnerabilities? What is it for? Do we need it? It turned out like we didn't need 2 of them anymore. They were just like part of dev. We don't need them. One of them is not good, so we upgraded it to a different version. And then the rest of them, I'm like, I just want to be on the newest one, and then that's it. And then I also like, I scanned it with Zap and smashed it a bit because that's how I am, and we fixed those things too. But the point is that like checking every single one of the dependencies myself made me feel a lot better, and then just like yanking out the ones we didn't need to reduce our attack surface. And there's one where there's been no updates in 3 years, and I'm pretty nervous about that one. But there's also 0 known vulnerabilities on it and thousands and thousands and thousands of downloads, and I'm like, well, I don't know, maybe I'll check it again in a bit. Anyone else?
One thing I want to mention about what's in your software. On Thursday, the United States announced a new executive order, and one of the big components of that new executive order is forthcoming standards in 60 days for this thing called SBOM, the Software Bill of Materials. And so if you don't know what's in your software, you have a crisis bearing down in a truck based on a document signed by the President of the United States. Have a nice rest of your Saturday.
Just going to share a link to that now. Yeah, I have to read that as soon as humanly possible.
I didn't hear. I haven't heard about that. That's good to know, though.
Oh.
Yeah, and it's. I don't think that the actual requirement will hit in 60 days, but the regulations will hit in 60 days, and it really does require you to know what you're shipping. And some of the folks in the chat were talking about cloning recursively. You have to know what's in your software. That is now table stakes for 2021. If you're shipping your software to someone else as a downloadable thing, as an app, as an IoT thing, this is a change, and it's going to be a very impactful one.
And just wait until they realize that SBOM has licensing information, and not all the licenses are compatible with your software licenses that you're using.
That sounds like a nightmare.
Oh yeah, it's real.
So I mean, I can add quickly that so software composition analysis is a nice thing to have nowadays. What's nice is that a lot of the repositories products that you can get for this, like Sonatype or Artifactory and those tools, have them built in nowadays, although sometimes at an extra cost. I know like Sonatype has a SCA that you can purchase, but it's prohibitively expensive, which kind of sucks. And so, sandboxing the code and actually like forking it internally is good. And I think that's also really important for Golang or Go, because Go allows you to import directly from GitHub or from an SVN. So you can have it so you're running Go code that is importing and building directly from code that just clones directly from github.com. I know that was an issue when I looked at some Go a few years ago, that we were worried about that. I don't know what the kind of security zeitgeist is on that now, because I know that Google is a fairly security conscious company.
Yeah, there are all sorts of things where if you clone someone else's something or other and then they change it and then you're in trouble. There is a lot of stuff like that when we depend on things. It's actually, so like GitHub is making those GitHub actions so that you can make your own CI/CD, and that's super cool, don't get me wrong. But if you use someone's GitHub action to call something in your pipeline and then they change it so it's malicious, you're screwed. And that is disconcerting. And so sometimes, like if I'm going to call a product from a company, right, and that company made that action, they want my money. So I assume that they're not going to try to hack me with their own action that they've made. But if there's some third-party person that's an enthusiast of product XYZ and they made a GitHub action to call it and automate it within this ecosystem, I don't know if I want to use the action they made. Or maybe what I want to do is copy their action and make my own action and like review the code myself, because I don't want to depend on someone else. So I guess one of the lessons that or takeaways here is that we don't want to depend on untrustworthy sources whenever possible, right? Like, right?
I'll add that if you want to see how, like, if you want to see how well your devs and like the stuff in your stuff, just go and figure out how many different libraries the devs use to create a base 64 string.
Oh, really?
I bet you there is like everyone is using a different implementation, even though like if you're using Java, there's like a built-in for it, right? And so that's a good test of like there's base 64 in most applications, and like somewhere in your org, and just go see how many times people are using and what library they're using. I'm sure it's going to be a number higher than 1.
When I was a dev, I honestly never thought about any of these things. Like, none of it ever occurred to me. I'd just be like, oh, I need this NuGet package so I can do this cool thing. Awesome. Install. Awesome. Compiles. Awesome. Bye. Writing next feature. Super happy dev. Yeah. Okay, so speaking of software development, the next question is, where should we store our secrets? So if we're making a custom application, where is the appropriate place to store our secrets? So maybe we should define what secrets are first. So what would an application secret be? A connection string to a database, perhaps? What else?
Username, passwords, API keys.
Mm-hmm.
Yep.
Things one
License
app
keys.
does not want to tell another app.
Hashes.
So are social security numbers? Are those an application secret?
No, those are a person's secrets. Yeah, so an application secret is a secret that an application uses, usually to identify itself to someone else.
Can an application tell a secret to another application if they're best friends?
Yes, they can. Yes, they can. And this is how they know they're best friends, is that they share the database connection string. And that way they can get it that the application and the database can be best friends.
So, yeah.
Or they use the same password.
Yeah, so they should not do that.
That's how you know they're besties, is they're using the same password.
Oh my god, no.
And it's probably like
Devs everywhere are taking notes right now. Oh my gosh. Oh. So salts,
We're getting some great
API
answers.
keys. video server passwords, OAuth tokens, like any token, any API key, any license key, anything a computer uses to authenticate itself to another computer in any way, to say, I'm the application and you are my database so we can talk to each other, or I am the application and you are one of the APIs in my backend. Hello, please look up this thing for me that I asked you to. And so those are a bunch of types of secrets. And then, so where should we store the secrets? Should we store it in our code?
No.
I want to make an obvious joke here. I want to make the obvious joke here, but like, it just seems too easy.
Well, Kubernetes tells me that I'm allowed to store it in environment variables.
It tells you you're allowed to, but that doesn't mean you should.
I know. I'm just.
So there are secret management tools that can like programmatically manage these things for us, like a password manager, but for a computer. And so we can put our secrets in there. That is a good place to put them. I have seen secrets stored in a myriad of places. When I was a dev, I kid you not, all of us, we would have a connection string in the code, of course, but we would also underneath have comments with every single different environment's connection string for easy testing. Yep. And we kept versions of every password ever and stored it in our password in our code repository. Right? Yeah.
So this is a... Oh, sorry, go ahead.
No, that was it.
So this is a little different when we're talking cloud apps, when we're talking IoT apps, when we're talking mobile apps. And you know, the way I like to think about it is how can you make sure that an attacker who takes a copy of what your thing can't get to it? And so in the cloud, using a cloud storage, a cloud secrets management thing, like the ones that are built into AWS and Azure now, is way better than putting it into your app in a configuration file or something else. In something like a mobile phone, there are APIs that the operating system that Android and iOS offers that lets the application store secrets in ways that are protected as well as the OS can protect them. And the trickiest one is the IoT device. I don't have a great answer for what do you do with the IoT device. If it's got encrypted flash, because the attacker can pull the hard drive or the flash chip out and just read everything that the thing is going to use at boot time. And so sometimes, depending on the design of the device, and I'm assuming we're making devices here, not just buying them, the device will have a little bit of encrypted flash storage that's locked to the CPU in some way, or the system on a chip in some way. But if you don't have that, what do you do?
I don't know.
Yeah.
There are so many new systems coming out all the time, and they're not accounting for this. Like the S in IoT stands for security, and notice there's no S. And it's really disconcerting for many reasons. A lot of the IoT things, and especially IoT medical devices, where they're put into someone's body often. I have a podcast, and this woman named Mary Moe came on, and she has a pacemaker, and she is famous because she hacked her own heart. And she actually changed things in her pacemaker. And it's like, the idea of that is terrifying. And it's not like they can patch your heart, right? Like, it's not like they can update it easily. I'm really concerned about a lot of things that are going on in the IoT space and like this bleeding edge technology space. We'll secure it later.
So I can tell you this is public, so I'm allowed to talk about it a little bit. I do work with the Food and Drug Administration on medical device cybersecurity, and they are working really hard on how do we get the entire industry to step forward, to threat model. How do we upskill the entire industry? And there's a great fellow by the name of Kevin Fu. He used to be at the University of Michigan. He's now at the FDA in the place where he should be. And Kevin did some of the very first academic papers on hacking medical devices. So they're super aware of this. They're working very hard on how do we make this better. And if you are working in medical devices, you should look forward to forthcoming, try and get the jargon right here, forthcoming second round draft pre-market cybersecurity guidance. And you should pay attention to that and help make it better, please.
Yes.
That's great.
Yes, definitely. This is fantastic news, Adam. Seriously. This is very good news.
It's not news that the FDA has announced all of this. I'm just echoing what they're saying. I'm not breaking news here today.
No, but I mean, it's good news in general. Like, rather than bad news. Not as in fresh. Someone, Hema is posting in the chat, I got recruited recently for medical devices related company to work on web app pen testing, including threat model, hardware pen test, as well as for medical devices. That's very cool, Hema. That's very, very cool. So there are more questions at the back of this book. So the next one, what are some of the potential threats that a mobile banking app could face? Like, if there's money, someone's going to want to steal money. But what else could a mobile banking app face as a threat? Like, what other risks are there? What would keep us up at night besides that? Like someone wanting to steal someone else's money.
I mean, just having how much money you have in your personal bank account being put out there for any number of reasons. Like, I mean, you might want to protect yourself if you have a lot of money or just a little bit of money, right? Like, or no money. Like, those could all be major sources of like embarrassment or blackmail or whatever, right? I mean,
so like the confidentiality of your information. Also, even maybe someone just getting your home address out of there. Or what if you're getting a divorce and you're trying to hide some money? Yeah, there's a lot of confidentiality issues. What other risks could there maybe be? Like, what else would we worry about when it comes to like a mobile banking app?
Well, I think especially on mobile, a lot of the risks that we see with that is down to essentially just misusing or misconfiguring what the mobile operating system offers, right? So as mentioned before, not properly using the API to store secrets, or you misstore the secrets somewhere else. I know I used to have issues with previous apps where they would forget to do something called certificate pinning, which essentially ensures the secure connection from the app to its destination can't be spoofed. And if that's not put in place, it's possible to perform a man in the middle between someone's phone and where they're trying to get to. And especially now, using Touch ID or the Face ID, if those are misconfigured, someone can just use an incorrect, facial data to access the app if you allow it to unlock an app with that feature. But
so you're saying someone could whack you in the back of the head, take your phone, unlock it, and then take your mobile app and unlock it with your face?
I mean, if you want to get really violent about it, sure.
I know, but like people, like sometimes we will come up with these extremely complex ways that people will attack us. But really, if I want your password, rather than me cracking it, me whacking you in the head with a wrench is a faster way if we're within physical proximity. And like, that's
Definitely.
a concern too. Sorry to cut you off. I was a little excited there.
If you want to have fun with your devs, have them threat model their house from like Home Invasion as a threat modeling
yeah.
exercise, because you're going to get like the ones that are like, oh, I'm going to lock my doors and stuff like that. Then you're going to get people like me and be like, what about the guy with the RPG across the street, or the tank that just comes through the side of the wall?
Yeah.
I would say what's good though is that Apple and Google's app review process for new apps is generally pretty good. So again, if you don't do these very specific basic things in your app, they will flag you and deny you access to the like App Store or Google Play.
Oh, that's excellent. That's great. I'm like,
I
I
wouldn't
know that at
say-
first it,
Yeah, I wouldn't say it's 100%. I don't know how good it actually is, but at least they know their own platform the best.
nice.
So if I to tie this to sort of the theoretical approach to threat modeling that we had earlier on, I'm listening to a bunch of spoofing, a lot of which has been about spoofing the authorized user of the phone in various ways. There's also some spoofing of the recipient. I'm going to convince Ray that, oh, I use this phone number with my mobile banking. For security, I don't use my regular phone number, so people can't send me requests without knowing what it is. Or there's repudiation, right? I didn't mean to send that money to you, Aaron, or Tanya. I know you told me you were going to send me the money for dinner last night, but you didn't. It hasn't shown up. Come on, just send it again to this phone number, please.
Yeah.
We've talked
Also-
about a lot of information disclosure ones. What about denial of service, right? So the phone, if we're out at dinner and I'm gonna send you the money via the app to pay for dinner and it doesn't go through because I'm on a cheap cell phone plan and it's not working right now, or we're downtown somewhere and there's just crappy reception. Maybe that's okay, but maybe one or the other of us doesn't have a lot of money and really needs the money that we just spent to come in. So denial of service, or maybe there's a crazy charge on my credit card and I can't send you money right now. And I've got to spend 30 minutes on the phone with the bleeping customer support people to try and unlock my ability to send some more money.
Or what about an elevation of privilege as we're going through Stride?
I was having trouble thinking of one right off the bat.
Well, so there was that fun attack from a few years ago, SIM swapping, where you would go into like, say, for example, T-Mobile, and you come off as a customer and you say, oh, I need a new SIM card. They basically will give you a new SIM card as someone else. So you will start receiving their calls and their text messages, which bypasses any of those like text multi-factor authentication systems. Because, I mean, you may have to get their password or you may have to guess it. But once you get that, you will now receive their text message saying, here's your code, right? And you can get access to their account.
But if
I think at least AT&T at this point had to put in like an additional authorization step if you wanted to do anything with a SIM card. Like that was their answer to it.
There was a great presentation by Philip Martin at Black Hat a year or two ago. Philip is VP of Security for Coinbase, and he talked about the advanced attacks that they're seeing. And he talked a lot about this set of attacks and said that he didn't think the responses that were happening at least a year or two ago were really sufficient. It's a great presentation. I really enjoyed it.
Cool. I feel like too with financial stuff, there's, so I don't know what it's called in the United States because I'm realizing all of you are located in the United States, but like in Canada, we call it FinTrack. And so they track movements of certain amounts of money in case it's funding terrorism. So for instance, if I go somewhere and I get a refund on my credit card for something, I have to agree to it. And like I have to authenticate before I'm allowed to have a refund. And I remember thinking, why? And it's because of FinTrack. Yeah, it's because that is one of the ways that they would transfer money amongst groups was using refunds for products. And also that's the way they would pay prostitutes too. Not terrorists, I mean people who do that. And so they realized that. And so you couldn't say, oh, I don't know where that money came from because I never authorized that. So you have to authorize certain things. And so all those FinTrack, there are tons of FinTrack rules that apply to mobile banking things specifically so that you can say for sure where this money came from. So no one can say, oh, I didn't know I was funding terrorism. And I mean, if you're moving more than $10,000 somewhere and you're like, oh, I don't know where this $10,000 came from. I'm sorry, that's pretty fishy. I definitely know where any $10,000 came from if it goes into my bank account. I think I would notice that. Yeah. So I have another question. So we've talked about, mobile app. What would be some risks that would apply to a smart car? Because there's different risks for a car than a mobile app. So, I mean, I would say like the first obvious one would be spoofing. And by that, I mean like tricking it into thinking you are the owner of the car and having it open for you wirelessly or keylessly because it has an electronic key fob and you have spoofed it and like pretended to be the owner, and then you are in the car and maybe you could start the car and drive away in the nice fancy smart car. What other types of things could we worry about like as a risk from for an IoT car, an internet connected car?
So privacy for sure. Right? All of these cars want to send their location all the time. And that means that the car company, plus whatever marketing libraries they accidentally stuck onto the car, because we were just talking about we don't even know what the software does. And if you think mobile apps and web apps are bad, cars are crazy. And so your location all over the place and interpretations of that location. So that's the first one that springs to mind for me.
Well, and it also doesn't even have to be the car sending the location, but if your car has Wi-Fi or, I mean, like even in the wheels now, they have, I can't remember what they're called. Little
Tire pressure monitors.
There you go. But like people just listening for radio waves can track your car throughout a city if they have enough points of places where they're listening for those radio waves, right? The Wi-Fi signals and stuff. So they can actually say, hey, this person goes here. Fitbit had that same thing with like military bases and all that stuff.
Yep. Ben saying in the chat, a car being controlled over the air, i.e. like a Wi-Fi, someone hacking when you're driving. It could also be someone able to get into the electronic control unit and implementing a chip. Yeah, I guess like if the computer's in the car and if someone is able to open up the hood, then theoretically they could potentially physically access the computer and potentially do a lot more damage with that. That's interesting too. Also, Ben is talking about a denial of service on a car so that someone can't start their car. That could be potentially really annoying, ranging all the way to extremely dangerous if you're trying to get away from someone really scary. Or if it's freezing cold out. I live in Canada where several months a year you can die from being outside.
Wait, which months can't you die from being outside?
I know. Well, now that I live on Vancouver Island, it's very different. But in Ottawa, I would say most months. Even one of the summer months we had, like they've been having deaths because it's been so hot. Like the climate's been getting very intense on the inside of Canada, but I am on the coast where things are a lot more chill, like socially and also weather based. What other risks could there be with a car? Like one risk could be they take over and they just play really loud music and it scares the pants off of you while you're driving and you get into a car accident. Or it turns the heat up really, really high and then, let's say, and then it melts your electronics or something.
And as you get older, like it's harder, like when you're looking for a particular place to like a store or to park, like if you can't turn down the volume, how are you supposed to see as well?
Mm-hmm.
What? That actually though, what if someone just changed the angle of your backup camera? So like, I'm really flexible. Yeah. I can turn all the way around and look. I don't have a backup camera. I have a really cheap first generation Honda Fit.
Or if someone deploys
She and I go way back. Yeah, what if someone deploys your airbag? That could really cause you harm. Yeah, that's a really good one.
I think either disabling or tampering any of the information delivery systems. So saying if they tamper with, it could be as low as like, I just tampered with the odometer. So it's just displaying the incorrect miles up to not displaying how much gas you have or misdisplaying how fast you're going. And in a lot of these systems, especially like I'd say the new Teslas, they put almost all the information on screens, like a big giant like iPad. And what if that's just turned off? Like you just don't see anything on it anymore.
Or honestly, with those big screens, that stuff is distracting, right? And it's not only distracting, it's way down there. And so I'm amazed that we haven't seen crashes as a result of people paying attention to the screen when they should be paying attention to the road around them. I mean, maybe we have, we just don't know about it.
Yeah.
I think I saw... I was going to say, I think I saw an article where I think it was Ford wanted to like use billboards, and like as you drive by billboards, it like plays an ad in your little display thing. Like, how awful would that be? And how distracting would that be?
Do they want to sell less cars? I mean,
as someone who occasionally does expert witness work at sort of the interesting end of information security, I look forward to testifying about what a bad idea that was for the remainder of my career. Because in 10 years, when they're no longer shipping software updates to them, and we can just do all of the things we just talked about via the thing that looks for the billboard and goes and follows whatever URL the billboard is broadcasting. Holy cow, that is going to be fun, because now we've got something on the outside of the car that is telling what is on by design. The thing on the inside of the car is obeying it. Woohoo.
Yeah. Like if someone targeted you and you're in a car that has not been patched for quite a while, I mean, imagine they change it so that you can't see, that you're almost out of gas. And then they bring you out, you're using the GPS to go somewhere. You don't know where you're going. You're in a strange place. And they bring you out into the middle of nowhere. And then they go pick you up and kidnap you. Let's say you're, a very high valued person where they could ransom you for a lot of money. That would be a really easy way for them to do it. And you pull up, you run out of gas. You're like, what's going on? It says I have lots. Where am I? There's a lot of scary potential there.
Yeah, and it doesn't have to be applied to someone who is going to get a big ransom. It can apply to someone where someone's obsessed with that person for whatever crazy reason. I mean, we're using the word obsessed, so literally I can say crazy here. But also what if it's happening in a divorce case where someone doesn't like who has the kids?
Yeah, actually,
What if you've got an
someone,
elder? Yeah. Sorry, go ahead.
a client, no, like a client was getting divorced, and their ex had access to all their bank accounts. And so then when they went to court to do financial disclosure, it's like, well, no, actually this. And it's like, how could you possibly know that? Oh, you've been in my bank account, like today. Okay. Yeah, divorces and especially people who have like mental illness, there's like sometimes they are dangerous. And that is truly terrifying because the regular rules of society don't apply then. Yeah, definitely super potentially terrifying.
And that also brought up a good point, is that if for updating these vehicles or to deliver updates, if it's anything like a cell phone, you not only have to have the car plugged in, but connected to probably Wi-Fi. And I know a lot of people who don't have Wi-Fi, mostly people that are in my life that are elderly, so like whenever they come over to our house, it's always like, your iPhone is 10 freaking months out of date. I'm like, well, yeah, because they don't have Wi-Fi. They don't have no need. They don't have a need for it. I would say that that's an edge case, but like I can't see it that happening for sure.
Well, as EV cars, like electronic cars or vehicles or whatever, like they'll become the standard, I'm hoping. And as we move to a more environmental future, and like eventually I'm gonna have to say goodbye to my 5 zillion year old beat up Honda Fit. And I'm gonna have to get another car and hopefully not be as abusive as I was with this one, but we'll see. And it will probably be an electronic vehicle, in which case then there's all sorts of digital concerns and people will get pushed into this eventually. Like not right now, but it's gonna happen, right? And then as there are less and less people...
Sorry, go ahead.
No, less people using gasoline, it can be quite a push, and that means people that aren't technologically skilled will still get one, right? Adam?
So we bought a new car a few years ago, and it was hard to find a new car that didn't connect to the cloud in a lot of ways. Right? And some dealers got it and were able to talk to us about, oh yeah, you can turn this feature off. But I couldn't find a car that did not have a 4G modem in it. But the other thing I want to mention about this, which is super relevant from the perspective of people building the technology, is new European rules require that you ship software updates for the expected lifetime of the device. And so if you're making something like a refrigerator or a car, you need to ship updates to the software to fix security bugs for as long as that thing is going to go. And this is another one of those problems and this is existing rule. This is not new rulemaking.
Nice.
It's the serviceability directive or something like that. We have not thought about how to maintain software for 10 years. Everyone's putting this new fun stuff in these systems, and it's totally changing the economics. It's totally changing the way companies have to think about profit and loss, and it's blindsiding a lot of folks.
Yes, Adam. I have to say though that like when I buy a phone and then 2 years later they don't want to give updates, it's like this device can last years and years and years. And then you're forced to either have an unpatched device. So I know people walking around with phones with a big crack down the screen and the thing is like 6-8 years old and they haven't had updates in years. But they're like, I don't have $1,000 for a new phone. Like, stop.
What's wrong with these people?
Yeah, they don't work in tech. They don't make 6 figures. They're normal. And like we have to protect those people too. As an industry, it's our job to protect everyone, not just the rich ones, not just the trendy ones. Okay, so there's one more question. Oh, did you want to comment?
No, I just had this funny thought running through my head through this conversation of like imagining ads being delivered directly to my car is like those television commercials that are like twice as loud as the actual show.
Yeah.
So you'll just be driving with your speaker, like listening to something, and your speakers just explode twice as loud for like a Burger King ad. Oh my god, that's my nightmare.
Yeah. Terrifying. Okay, one last question, and then we're going to wrap up. And I would like each person to say a takeaway or their favorite thing from the show that they want the audience to take home. Okay, last question. Name a few different types of security functionality or like security controls that would potentially be offered in a modern framework. So programmers usually program with a framework. So like for C#, it's .NET. For Ruby, it's Ruby on Rails, etc. You can program some languages without a framework, but it's way better with a framework. It offers lots of stuff, like functionality, things that it can do. What are some security functionality that could potentially be offered in a modern framework that we want all of you to use? So I'll start. So some of them offer output encoding. So rather than you having to write it or call it specifically with a library, you can just put .encode, URL, whatever, and it'll just do it for you, and that is nice. What else could be a security control that might be offered as part of a framework?
Like auth-z. So there are a lot of frameworks that do have that stuff built in, and like they're hard to use, and the developers just roll their own. They're like, I'm gonna just write authorization how I think it should go, and like having better models out there would probably make things a lot easier for devs.
Yeah.
Mm-hmm. Yeah, I'd say it's one nice thing about the kind of new single page apps like React and Angular is a lot of them have like output encoding built in. But with any of these frameworks, though, whatever they offer, they have to be properly configured. Because if they're misconfigured, then they just won't work, right? So, because a lot of the times it may not be come out as secure as default, right? It might not have that turned on as by default, and you may have to turn it on. And there are still ways to implement it poorly. Like if you use, say, like Spring Security, and again use their like auth packages or their auth libraries, there's plenty of ways to implement that poorly, right? So you still have to be careful there, even though it's offered. But it is still, to me, better than reinventing the wheel.
And writing your own. Yeah, I agree.
Mm-hmm.
I agree. So like authentication, authorization, Ben was saying, so there's some that will pass an anti-CSRF token for you. So I know .NET does that. I'm pretty sure Ruby does that, and a few others. Ruby on Rails will actually block injection and cross-site scripting attacks by default. Like, it's pretty good. My friend Nikki Becker, who will be on one of these episodes later in the year, she made an intentionally vulnerable app in Ruby, and she's like, damn, I had to work so hard to undo all of Ruby's defenses. So difficult. I'm like, yay, that's what we want to hear. The more we build these things into frameworks, the less devs have to memorize and reinvent the wheel themselves each time. And yeah, I'm a big fan of letting someone whose entire job is to write that security control to do it for me, rather than doing it myself, if that's an option.
And that can be.
Go ahead.
So, thanks. That can be either the people who write the frameworks like Ruby on Rails or Go, but it can also be someone who works for your organization. I know
Yeah.
there's a really powerful pattern of the security team writes the logging framework, the IAM, the secret storage, and then says, here at this company, the way we now do this is this. And so both it's great when it's by default out of the box, but there's also things you need to do locally. So anytime we can help people get it done, I'm a big fan.
Yes, I agree. So that's all the questions, and now we're going to do a wrap up. And so we should just stay on Adam, because I'd really like you to, first of all, promote anything you want to promote. And then also, if you have like a key takeaway that you'd like to share with the audience or your favorite part.
Okay. Hang on 1 second. So
Sure.
I would like to
book.
promote my way too thick book, this very heavyweight how to threat model, and also say that the reason that I wrote this is to be an authoritative reference rather than to scare anyone. You can get started threat modeling by asking the 4 questions. What are we working on? What can go wrong? What are we going to do about it? Did we do a good job? And to the point Tanya was making, don't let anyone tell you that you're not doing it good enough. You've now heard it from me, the person who wrote the book on threat modeling, that is good enough, and that you should get started there. So that's where I'll end.
Yes. Aaron, do you want to go next?
Sure. So again, Ray and I have a blog, a security blog, AppSec specifically, hella-secure.com. Or you can also follow me on Twitter at hella-secure. I'll apologize in advance because I haven't contributed to it in a while, but I have to be in the mood to write, and I don't want to write something if I'm not in the mood because it won't come out good. I'll say for takeaways, almost.
Output encoding is hard, man.
I would think as far as the discussion, though, and I read a good article about this a couple weeks ago about shift left, and that I think still fostering a good security culture in tech is probably one of the best first things you can do, right? Because having tech's involvement in secure design is very, very important, right? I would say another quick thing is to think in secure defaults, right? Where the default behavior of an application is a secure behavior, right? And that if we need to make it so that, there has to be something about it that is a little less than secure, it has to be opted into. And I think lastly is to just, like I just previously mentioned, is not reinventing the security wheel, right? There's no point in trying to roll your own security functionality if something already known good exists. And this is true for most semi-mature, mature organizations. They generally will have their own authentication platforms, their own service authentication platforms, their own secret storage platforms that already exist. So be sure to consult with who is in the security team to see what already exists in your organization and reuse those.
Nice. Ray, how about you?
Yeah. Let's see. I'm gonna say, read our blog that we've been kind of ignoring for most of COVID. It's been a rough year for everyone, so. I'm going to say from a threat modeling perspective, don't be afraid to fail. Like, just try. Like, there are no stupid threats. Like, the worst thing you can do is just erase it from your whiteboard or from however you're documenting it, right? Like also some stupid threats are actually in fact not stupid once you actually think about it and you're like, holy shit, like this is an actual thing. And that's happened to me and my developers a few times where we're just like, everyone was like, that's a bad idea. And then we're like, let's just throw it on there. And then as people started to think about it, it became, well, this is something that we actually need to fix. So like, don't be afraid to try and fail, because like everyone, like no one else knows, like no one else in the room is going to be a threat modeling expert like 99.9% of the time, right? Like, so from the secure design perspective, I would say, let's see, I would say like having like an opinionated ideas on how to do development internally definitely helps. Like, it makes things more consistent. Using things like really well, like frameworks, libraries, is easier. I mean, like, not saying you shouldn't try new things, but I don't know. I don't think there's one good way to do secure design. And like most companies' use cases are completely different. So like you have to do what works best for you and your company and your developers. So like keep that in mind when you're like thinking about secure design. It's like what makes sense for us as a company and how we want to protect our customers' data. And then I was going to give a shout out to Dr. Pepper and cream soda. It's a delicious mix. That's all I have.
Yes, we were talking about earlier about me adding one of the questions to the end of the chapter was going to be which is better, Dr. Pepper or cream soda? And then Ray was going to come up with why not have both? I totally forgot. Thank you, Ray. Oh. So I would say my key takeaway is that you're going to get better at threat modeling each time you do it. It's okay if you're imperfect. It's way better to make efforts towards this end goal of creating more secure software and defending against potential threats than freaking out about perfectionism or if someone else is going to judge you for not doing it the exact same way that they do it. And that if people are kind of crapping on you that you're not following this exact methodology, that they could watch this video and maybe learn something about chilling out and actually getting security done instead of worrying about being exactly adhering to rules or things that you read in a book, says a person who wrote a book. I want to thank everyone for being on here. Vandana Verma, who was on earlier and had to leave, Adam Shostak, Ray LeBlanc, which kills me because I'm French, so, and Aaron Lord. This has been really great. I want to invite all of you to come next month. So in exactly 4 weeks from today, we will be doing chapter 4, which is about secure coding. So June 12th, 1 p.m. Pacific time. A bunch of us are going to be talking about secure code, secure coding. I'm going to just get all up about the security headers again, probably, because I just can't help myself. I'm going to rant a bit about Rust. I really like Rust. I'm Tanya Janka, and I wrote this book, and I really want to thank you for tuning in. I want to thank you for your really great remarks. I want to thank you for hopefully subscribing and clicking the thumbs up button, purchasing my book, and doing all those things, for following my guests on their various social media and checking out Adam's book and the blog. And Vandana actually does tons of stuff, and she was being really modest. And I hope to see you next month where we can discuss this again and I can hear more of what all of you have to think. I really appreciate you sharing with me. Thank you very much. Until next time, we are Alice and Bob Learn.